Hey everyone, and welcome to our lesson 5 of our multi-agent reinforcement learning series. Today we are exploring the future horizons of multi-agent AI from current achievements to future possibilities. This is a special lesson because we are not just looking at where we are today, but where this field is heading. We are at the intersection of some of the most transformative technologies in AI, and I'm very excited to share this journey with you. Now let's dive in. Before we begin, let me briefly discuss our student project showcase. Each group has 3 minutes to present, focusing on 3 key areas. Maybe first, clearly define your problem and application scenario. What real-world challenge are you addressing? And second, discuss the technical challenges you are identified and your proposed solutions. And third, highlight your innovation points alongside with the feasibility analysis. And your peers will evaluate it based on 3 5-star criteria: technical feasibility, innovation, and practical value. So keep this in mind both as presenters and evaluators. Okay? Today we'll navigate us through 3 major frontiers in multi-agent AI. First, we'll examine what happens when foundation models meet multi-agent systems. Bringing together large language models with multi-agent learning, this is the most exciting recent development, I think. Second, we'll explore human-AI collaboration and what true partnership looks like, and how can AI systems work alongside humans as teammates rather than just tools. And third, we'll discuss explainable multi-agent AI. As these systems are deployed in critical applications, understanding these decisions they've made becomes crucial for trust and safety. After these 3 frontiers, we will have an open discussion about technical breakthroughs expected in the next 5 years and the ethical considerations. And finally, we'll outline your learning path forward with concrete resources and next steps. Now, let's dive into our first major trend: foundation models meet multi-agent reinforcement learning. Let us think. What happens when large language models meet multi-agent systems? We are witnessing a fundamental shift from fixed capabilities to emergent abilities. Traditional MARL requires agents to learn from scratch for every task, needing millions of interactions, but LLM-powered agents leverage pre-trained knowledge and then adapt. This is the game changer. Why is this exciting? There are 3 key reasons, I think. First, common sense reasoning is built in. These models already understand the world. Objects fall down, social norms exist, cause and effect relationships works in predictable ways. And second, natural language becomes the coordination media. Instead of learning such abstract protocols, agents coordinate using language like humans do, making it more intuitive and interpretable. And third, rapid adaptation to new scenarios. Because these models have seen diverse data during pre-training, they quickly adapt to situations never explicitly trained on. So we know that ChatGPT and other similar models have remarkable capabilities for multi-agent systems. They can role-play different agent personalities. You can create diverse agent populations without training separate models. They generate strategies in natural language, making them interpretable and easy to modify. And they understand complex social concepts like cooperation, competition, and maybe trust. And another one is multimodal foundation models, which can go further, possessing observation spaces combining vision and language, enabling better coordination through shared representations and understanding context beyond by the raw numerical data. So here's the fascinating example. Researchers deployed GPT-powered agents in virtual marketplaces to negotiate and trade. These agents developed emergent economic behaviors, learning to bargain and detect deception. These strategies weren't programmed but emerged naturally from their interactions. This emergence of sophisticated social behavior is what makes this approach so powerful, right? Of course, we have the challenges remain. How do we fine-tune LLMs for collaborative behaviors when they are trained on individual human text? And can agents deploy such shared understanding through language? And how do we balance autonomy versus coordination? So emerging solutions maybe include prompt engineering to encourage cooperation. For example, we can say that you are a part of a team working towards a common goal and consider your teammates' needs. And also, multi-agent RLHF trains teams based on the human feedback about how well they work together. And the structured communication protocols provide standardized formats for efficient agent-to-agent messages. As I say, the future is not just intelligent agents, but socially intelligent agents, right? Here's our quick poll. In which scenarios would LLM-powered multi-agent systems be most valuable? Such choices maybe include virtual customer service team and scientific research collaboration and so on. Think about which would benefit most from LLM capabilities and why. Okay, share your thoughts. Okay, a great insight. Each application has the compelling potentials, right? We know that. And now let's move to our second major trend, human AI collaboration. Okay, currently AI is a tool, humans command, AI executes, but the future vision is fundamentally different. Human and AI co-thinking together and making joint decisions. To achieve this, we need breakthroughs. Okay, the first is theory of mind. AI understanding human intentions, beliefs, and goals, not just explicit comments. AI needs to model what we are thinking and what we know and what we are trying to solve or achieve. So the second is adaptive collaboration. AI adjusting to individual human styles. Some people prefer detailed guidance and others want autonomy. AI must learn these personalized patterns. And third, proactive assistance. AI anticipating needs before explicit requests, like a good teammate who notices you are struggling and offers help without being asked. So the key insight is every human has unique collaboration preferences. Just like human teammates learn each other's styles over time, AI agents must learn personalized teamwork patterns for each human collaborator. Okay? So the biggest challenge is reading between the lines. Humans don't always say exactly what they mean. Maybe, can you help me? Can you help with this? Might mean they take this completely off my plate. And well, let me think might signal uncertainty needing support or a request for space. So the technical approaches include behavioral modeling. Learning from the past actions. If the system has worked with you before, it learns your patterns, okay? And sentiment analysis, detecting emotional states. If your typing speed increases and message gets shorter, then maybe you are stressed, okay? And goal inference using inverse RL. Infer what objective would make your action rational. And active querying, asking clarifying questions just to make sure I understand. Do you want me to handle this completely? So a fascinating frontier is inverse MARL, learning from observing human-human team interactions. By watching successful human teams, AI learns effective collaboration patterns that feel natural. So where will we see human AI teams? Maybe healthcare, creative industries, education, so a lot of places, right? So the key principle is AI acts as a true team member, bridging the capabilities and taking initiatives, not just a passive tool, right? Okay, now let's move to our third major trend, explainable multi-agent AI. critical for real-world deployment. So we know that single-agent systems are hard to interpret, but what about the multi-agent systems? Yeah, the complexity is multiplied. Okay, so we need to answer, why did agent A choose that action, and how are agents coordinating implicitly, and what caused emergent team behavior. In critical applications, transparency is mandatory. Like healthcare need to explain AI-assisted diagnosis to patients, and finance must justify algorithmic trending to regulators, and autonomous vehicles must explain accident causations. So, and legal systems need accountable AI-assisted judgments. So without explainability, we cannot deploy responsibility in the high-stake domains. Okay? So there are 4 technical approaches emerging. The first one is attention visualization, showing which agents or observations influence decisions through the heat maps of coordination patterns. This reveals implicit communication in the system. And causal analysis, identifying cause-effect relationships using counterfactual reasoning. What if agent B has done X instead? How would that change the outcome? This shows why things happen as they did. And natural language explanations, using LLMs to generate readable justifications, like agent A moved left to create space for agent B's attack. Intuitive explanations without technical jargon. And interpretable architectures, designing transparency from the start through role-based decomposition with clearly predefined agent responsibilities. Squad, defender, attacker roles may make the behavior easy to understand. Okay, each approach has strength, and combining multiple techniques often achieves better explainability. And here is the typical trade-off. Deep RL offers high performance but low interpretability, and decision trees are interpretable but have limited performance on complex tasks. Our goal is the upper right corner, both high performance and high interpretability. This is challenging because of the fundamental tensions between these objectives. So the important question is, should we sacrifice some performance for explainability? And in which applications is transparency absolutely non-negotiable? So I'd rather argue in safety critical domains like healthcare and autonomous vehicles, transparency is non-negotiable even at some performance cost. A slightly less accurate system we can trust may be better than a more accurate black box, right? But in internament applications, maybe maximum performance matters more. And what do you think? Okay, now let's discuss the future opportunities and the challenges ahead. There is the group activity. Let us think which breakthrough is most likely by 2030. Like the multi-agent system matching human team performance in complex real-world tasks and so on. And think about which seems most likely and what technique barriers need overcoming. Okay. So the follow-up is, for your choice, what's the main technical barrier standing in the way, and what breakthroughs are necessary? Okay, just think about that. And for the ethical consideration and social impact, there are some the critical ethic questions we must face, like responsibility and accountability. When multi-agent systems make mistakes with real consequences, who's responsible, right? And there is also the economic impact and some other items concerned about the ethical and social impact. And what's your view? Okay, you also need to think about that. And now we need to address security concerns and potential misuse. There are maybe some risks include coordinated cyber attacks by malicious agent swarms, marketing manipulation through algorithmic collations, and distributed surveillance system and autonomous weapons systems. So mitigation strategies require multiple approaches like technical solution, policy framework, research, education. As researchers and practitioners, we have a responsibility to get these technologies development ethically. We can't just build it because we can, and we must think carefully about whether we should and what safeguards are necessary. Okay, now how can you continue this journey beyond this series? I think to excel this field, building strong theoretical foundation is necessary, like in theory, probability, and statistics, and optimization, distributed systems. And there are some key papers to read. Please follow my GitHub page. And also, the hands-on experience is crucial for some open source framework and some platforms we need to practice actively. And the practical advice is start with the simple 2-agent games and implement basic algorithm from scratch. This teaches far more than just reading code, then gradually scale up the complexity. Okay. And another one is don't learn in isolation. So we can attend the conferences, NeurIPS, ICML, ICLR, and so many leading conferences, and join the online community and contributing back. So being an active community member accelerates the learning dramatically. Yeah, I can say that for sure. And for the projects idea to get started, I think concrete projects idea at different levels, maybe beginners, implement independent Q-learning in Greek words and compare them in DDPG versus IQL in cooperative navigation. And yeah, this is the beginner's level. And for advanced level, maybe you can scale up MARL to more agents using main field approximations and build human AI collaborative games with adaptive teammates and research novel coordination mechanisms for heterogeneous agents, and pick projects that excite you most and match your skill level. Then push slightly beyond your comfort. So, okay. And let's recap our entire journey about this series. The lesson 1, MDPs to Markov games. Lesson 2, algorithm design, and lesson 3, learning dynamics. Lesson 4, real world challenge, and now today the lesson 5, future horizons. From foundational concept to cutting edge frontier, you can now have the knowledge to explore and contribute to this exciting field, I think. The future of AI is not just intelligent machines, but intelligent machines that work together. So I think the key takeaways may be the multi-agent AI is rapidly evolving with LLM integrations and enabling capabilities impossible just a few years ago. And human AI collaborations and explainability and ethics are crucial for responsible deployment. So this field needs diverse perspectives and innovative thinking. So your ideas matter. So keep learning, keep building, keep questioning. The future will be shaped by people willing to engage deeply with these challenges. Okay, now I want to say thank you for your engagement throughout this series. I love to hear your questions, thoughts, or ideas. What aspect excited you most and what challenges do you want to tackle? Please stay connected. Continue discussions in our learning community and share your projects. And please remember, this is not the end, but the beginning of your multi-agent AI journey. This field is evolving rapidly, and the next breakthrough might come from someone in this room, okay? And I'm excited to see what you will accomplish. And thank you, and good luck on your journey.